we will be able to interpret lines of regression. Okay, cool. That made no sense, Brendan. But yeah, we'll deal with Minvu is just joining now. Okay, cool. All right, so let's go have a look at this. So before we get into the actual lesson, let's talk about the dumb fact. The dumb fact is eventually I had to slip in a super nerdy fact. So the super nerdy fact that I thought I would put in here is Order 66. So Order 66 was actually in the third Star Wars film. It was the order that was given by Emperor Palpatine, which was to execute all of the Jedi because they had become corrupt, inverted commas. Of course, they hadn't become corrupt. It was actually the Emperor that was corrupt, and he ordered all these Jedi killed so that he could take over as Darth Sidious. So yes, I say there's an asterisk next to the all, because if you watch any of the extended canon, you'll find that a lot of Jedi actually still survive. But you know, still whatever. Anyway, for those of you guys, I won't get too bogged down into nerdiness because I know a lot of you guys probably don't care. Yeah. I do like Star Wars, but you know, I'm not gonna be like, to be completely honest with you, I've only seen I think every movie once, so I'm not like a Star Wars nut that's been like, I've seen all the Star Wars films like 6 times. Like, no way. I've seen them once or twice maybe. I did mark the roll, Min. You were late, so I will mark you as present. Okay, so let's talk about this. So as I've told you guys already, we're going to be interpreting. So interpreting means like coming up with explanations or sort of like trying to understand terms. Now, there is a word here that you guys may not have seen before, which is regression models. So what this essentially is like essentially what we're talking about with regression is we're talking about linear models. What we're talking about, what the real word regression means, to go back to basics, essentially. So when we look at a regression model, we're trying to simplify a model. We're trying to simplify a line. And that's why when we talk about this, that's what we're trying to do. To regress means to re means to go over or to go back to, and gress, I don't know what the word gress means, but I assume it means to move, because egress means to go forwards. So have you seen Star Wars Vision? No, I have not. I haven't seen any of Clone Wars and stuff like that. And I was actually going to watch it when it was on Netflix, and then they moved it to Disney. I don't know, Disney Plus and the pirated website I used to watch anime has been blocked. Yeah, I know, sad times. Let's grab a look now. I actually don't know who said that because just no. What we're going to do now is we're going to go back to grab a look at what we looked at last lesson. So last lesson we talked about the line of best fit. Okay, hold on, something. My computer is trying to do something weird. So line of best fit is essentially what we first talked about, is how we can generate the line of best fit using programs like Google Sheets. We can also use our calculators essentially. And I told you guys for 7E, I want you to put them into a graphing software. But for question 4 and 5, I wanted you just to try to guess. So that was sort of me explaining what you needed to do with chapter 7E. Then with 7, then I talked a bit about this term. What is this line of best fit? So R being, of course, how close to a straight line it is. So what can we call this line of best fit? Well, this line of best fit allows us to make predictions of the data. allows us to take this data and regress it to a point where we can be like, cool, we can use these numbers. Now, the first part that we did is we talked about, well, how can we use the line of best fit? Well, if you are looking at values that are around the data, in other words, the data circles the values, then what you've got is you've got interpolation. What you're doing is you're predicting something within the neighborhood. So it's actually more accurate than the other type, which is called extrapolation. That's when you're saying, okay, given this information, what's going to happen next? Or given this information, what happened at the beginning? It can be a little bit less accurate because you don't know how this will work, but scientists use this all the time to make predictions. We look at the current vaccination rates and make a prediction about when we will achieve certain vaccination targets. We look at the current global warming rate and make predictions about when we will reach certain temperatures, when the sea level will reach certain levels. We can look at fossils and be like, okay, given the shape of this fossil, we can predict how big this fossil was, how big this animal would have been, 10 million years ago, so on and so forth. So that's what we use extrapolation and interpolation for. And then I talked to you guys a little bit about how we could use an equation like this to make predictions. We could go, okay, cool, where are these values going to be? How do you actually do that? And I said, that's pretty much all the information you needed to be able to do this exercise here, and then this exercise here. But the one that I did leave out was 7F. So what I'm going to be doing is talking about 7F and 7H today. So they're the goals for today. Now 7F we're going to do relatively quickly. In 7F, what we're going to do is I'm going to show you guys firstly how to create a line, of how to create a line of best fit. So to do that, what we're going to do is we're going to put in some values. So what I've got here is I've got a list of different metals. So titanium, copper, chromium, iron, nickel, cobalt, scandium, and manganese. And I've got for these ions the atomic number, and I've got their melting points. And so what I'm going to do is I'm just going to plot these on the graph. So this is what we're going to do. When you go 23, that's going to be at 1668. So that's going to be about here. We've got maybe a little bit higher, maybe like here. We've got 29 with this, which is 1084. And so that's going to be about here. We've got chromium, which is at 24, which is going to be at 1860. At this point, someone's like looking at this and thinking, sure, we need to copy this down. My answer would be hell no. Normally what I would do is I would print this off and separately we would work on this together. So I'm just going to show you guys this iron 26. So iron 26, that's going to be at 1538. So that's going to be 1538. So it's going to be about maybe there. And so then what we would do is we'd plot all these points. Here is one I prepared earlier. You can actually see how well I did for these. Looks like I got 29 really wrong. Yeah, I did. Look at that. I missed that completely. But the rest of them I did pretty well. And so what I want to do is I want you to look at these points here. Now these points don't really make a very good linear line. But what we're going to do is we're going to see if we can fit a linear line to this shape. Give me a second. I'm just going to quickly grab a ruler so that I can do this properly, because I don't want to try to do this freehand. So 1 second. So I got a ruler. So here we go. Okay, line of best fit. So how do I do this? Well, if I go and look at these 3 points here, these 3 points seem to be in a bit of a line. And if I look at these 2 points, sort of be a bit of a line. So what I'm going to do is I'm going to try to draw a line of best fit. Now, the line of best fit that I'm going to do is going to be, it has to be a little bit lower than these values because I have to try to include these values underneath. It's probably going to go up about here. So if I had to draw a line of best fit, I think I would probably draw something like this. Whoopsies. There we go. I think that's pretty good as it goes. Maybe a little, maybe it should be a little bit higher than that. Maybe about there instead. Yeah, I'm pretty happy with that. And that's my line of best fit. Now, if you guys are looking at that and you're like, oh my God, sir, can you just change the line of best fit? And the answer is for this, in this case, yes. Now, if we were doing this properly, and when I say properly, I mean if we were using the proper least squares regression algorithm to find out the exact line, then we would be able to get an exact line of best fit. But what I'm suggesting, trying to get you guys to do for 7F, is not to try to get the exact line of best fit, but try to get an approximate line of best fit. So I would say this is an approximate line of best fit. I'd say this is pretty good. So the next step that we should do is we should try to figure out if this is our line of best fit, then what is the equation of this line of best fit? To do that, what I would do is I would take 2 points where they cross the axes. This one here looks pretty good. And then this one, let's see, where's another one? This one here looks pretty good. So I use those two to figure out my rise and my run. So we've got a rise of 1, 2, 3, 4, 5. So we've got a rise of 1800 to 1300. So we've got a rise of negative 500. We've got a run of 1, 2, 3, 4, 5, 6. We've got a run of 6. So negative 500 divided by 6 is going to be about, 500 divided by 6, 83. So we've got, this is going to be about negative 83. Then what we could do is we can then take that and we can substitute a value in to get a value of, to get an accurate value of the equation. What do I mean by that? Remember the formula, we would write down y equals mx plus c. Now this stuff here should be practiced for you guys. You might be like, so this is linear graphs. And it's like, yes, this is linear graphs. If you don't remember this, it's a good chance for you to practice it because we will need to be able to do this. Y equals negative 83x plus c. Substitute a value in. We're going to substitute maybe, let's use this one. So 1084 equals negative 83 times 29 plus c. That's going to give you 1084 equals, so if I go like this, 83 times 29, 2407 plus c. So that gives me my final answer of c equals 1323. So that's it, gives me my final answer is y equals negative 83 x plus 1, 3, 2, 3. And that's what I calculated using my line of best fit. Now, for those keen of you to observe, you guys can see, hey, what's that thing right above where you wrote down that answer? You guys should be like, oh, look, what's this? That is the actual correct line of best fit. So you can see that I have not done a very good job. My gradient is a little bit too steep. I think they were suggesting, so that would be, that would mean that they would be suggesting a gradient that looked a little bit more like, I can't really draw this out exactly, but actually I could draw this out exactly. How would I draw this out exactly? Let's actually see how badly I did, ladies and gents. So we're going to substitute x equals 22. And what that gives you is y equals, when I substitute 22 in there, I get negative 52 times 22 plus 2805 gives me 1661. So 1661 is about here. And then I'm going to substitute x equals 28. What do I get when I substitute x equals 28? I get 1349. 1349. So they reckon that the line, or the actual line of best fit, looks more like this. So yeah, I can see that. That makes a little bit more sense. But still, like, the point is that I'm not looking for super duper accuracy here, ladies and gents. I just want you guys to be able to get a line of best fit and then find out what the equation of that line of best fit is. If you're lucky and your axis goes to 0, you can get your, you can just read your y-intercept off the line. But as you can see, because our minimum here is 20, not 0, we can't read off the graph straight away. So what I'm going to do here, I'm just going to do this for a second. Actually, 7f is, this is the 7f. So fittingly, so it's a, so if you look here, the table below shows the weight in kilograms. Construct a scatter plot of this data, fit a least squares regression line, and determine its equation. So it doesn't have to be necessarily super accurate, it just needs to be as good a line as you can get. And then you need to work out the equation of that line. So using that method that I just went through, write an equation of the regression line in terms of variables, glucose and weight. So what that just means is replace the x with weight and replace the y with glucose. And determine the correlation coefficient to 3 significant figures. Correlation coefficient, that just means P. So if we actually go up and we actually look at how this is done, we can see that. So they go about doing it with a, they go about doing it by sketching a graph using the program. I don't want you guys to use a program for this. I just want you to give your best go to see if you can draw a line that best summarizes your data. That means that when you go to correct this, you may not get the same answer. You probably won't get the same answer as the one in the back of the book, and that's completely fine. I don't care, as long as it's, you know, but I want you guys to be practicing how to find the equation of the line. If you do check the answer in the back of the book, hopefully you're close, but yeah, it doesn't matter if you're not exactly there. So before I jump into going through the next thing that I want to discuss with you guys today, are there any questions or queries or issues with how to add a line of best fit to some data and how to find out the equation, or are you guys okay with this? So, with none of you guys saying anything, I'm going to assume you guys are cool with this. So this is what you need to do for 7F. So the last topic that I wanted to go through with you guys is 7H. And what we're going to do in 7H, and like you write this down, is we're going to talk about these 3 steps. We're going to talk about how to interpret the equation, how to interpret the gradient, and how to interpret the y-intercept. Now, as we go through interpreting things, I'm going to give you guys fill in the blank statements. Now, these fill in the blank statements, I would strongly suggest that you put into your bound references and you guys use. You do not, if you are good with English, you are more than welcome to freestyle and add your and write it your own way. But for those of you guys that find some like that come from an EAL background, I would strongly suggest just using the fill in the blanks. Now, the trick with interpreting questions is this word interpret. Whenever you see this word interpret, straight away your mind should go to one thing, and that should be words. I have, and I'm going to be very clear with this, I have marked a lot of students' tests and exams, and there will be a question that says interpret something. There might be interpret the gradient. Okay, and aren't always, every time we ask students to interpret the gradient, I always get at least 3 students to do this. Or something like that. That is not interpreting. That is writing down the gradient. And although that's interesting and useful, it shows me mathematical understanding, those are not words. Those are numbers. And so inevitably, the students either get 0 marks or they get half a mark. And they go, sir, why didn't I get the marks? I wrote down the gradient. The question said interpret the gradient. I wrote down the gradient. But that's not what the question didn't ask to find the gradient. The question asked to interpret it. Now, we've done interpreting before. Yes, we have. If you go back in time, we did interpretations here. I said interpreting a scatter plot. When we interpret a scatter plot, I gave you this phrase. That phrase gives you a way to talk about a scatter plot. It gives you a way to talk about it in words, not like it doesn't say give me the Pearson correlation coefficient when it says the strength. It just says use the word strong or weak or moderate. We're going to be doing the same thing now, except we are going to be doing it on these 3 ideas. Let's start with interpreting the equation. So what I'm going to do is what we need to do with interpreting the equation is turn an equation into a worded equation. So let's have a look at this. The amount of fuel left in the petrol tank of a car can be predicted based on the kilometers driven using the equation blank. So how can we turn this? Let me just check the next slide. Yep. How can we turn this? How can we turn this into an equation? Turn the equation into a worded equation. So what we're going to do here is we're not going to be interpreting anything. We're just going to be making a worded equation. The reason I'm showing you this is because this does show up a lot. Okay, so how do I turn this equation into a worded equation? All you do is you need to replace the variables. So let's look at this question. The amount of fuel left in the tank of a car. So that's going to be one of the variables. That's going to be our response variable. Response to can be predicted based on the kilometers driven. So that's our explanatory variable. That means that when we look at this equation, we can turn this into a worded equation by changing it. So instead of Y, we're going to say petrol in tank equals negative 0.08 times, we're going to write, this is the driven, the based on the kilometers driven. So distance driven plus 40. Now, even though I just told you guys, this is not really interpreting the equation. This is just converting the equation into worded form. So I'm actually going to change the title of this slide because I'm actually a bit disappointed in myself that I wrote this down as the title of the slide, but that's okay. Nobody's perfect. Worded equation, perfect. So this is all that you need to do. The reason I'm showing you this is because I've actually seen this show up in a lot of questions, especially in 7F. So just be aware that when you get a question, you just got to figure out, well, which of these is the explanatory variable, or which of these is the independent variable, and which of these is the dependent variable. In this case, the amount of fuel is dependent on the kilometers driven. I'm going to keep this slide up for about a minute, about 30 seconds longer. I'm going to change the slide to something a bit different. Okay, I'm going to change the slide. Something a little bit different now. What we're going to do now is we're going to interpret the gradient. Now, what does interpreting the gradient mean? This means giving meaning to the value of the gradient. Okay, so rather than just say, rather than just saying, okay, you know, this is the gradient, m equals whatever, we want to give meaning to it. So how I do it is I use this sentence here. And so this is the sentence that I strongly suggest you use. For every 1 unit of x increase in x, the y will increase or decrease by the gradient and units. And you might be looking at it like, what the hell is that? So let's say you've got an equation. I also don't like this slide. Man, I've really done a bad job of making the slides. I should have checked them over before I presented today's lesson. In this slide here, we've got, for example, x, or our explanatory variable, is hours studying. And y, or our response variable, is percentage on a test. And so you can get a regression model that looks, an equation that looks like this: 15x plus 20. So the more hours you study, the greater your test results are. So I'm just going to give you guys a second to jot this down first, and then what we'll do is we'll work on it together. In the meantime, I'm going to try and fix this picture. This picture is completely wrong. I think I must have changed my mind as I was doing this. particular whatever. Okay. That's not going to work at all. So then 1 would be 35. So that looks a bit better. Let's go with that. Croissant. I finished my croissant. Ages ago. It was a good croissant though. We are now out of croissants. It's sad days from now on. Okay, so I fixed up the picture on the right here to actually match the equation. So that's cool. Right. Now, what will most people do? They'll see this question. They'll see the question, interpret the gradient. And there will be at least 2 students that will just write m equals 15. Yes, that is the gradient, but that is not how we interpret it. What we need to do is we need to give meaning to that 15. What does that 15 mean? Well, that 15 means that if I do 1 hour of study, I can increase my score by 15%. If I do 2 hours of study, I can increase my score by 30%. So the 15 is a conversion between the hours of study and the percentage we can get on the test. So let me show you how I would then interpret this. Remember, the second you see the word interpret, that means that you need to turn this into an equation. So you need to give words. So what are the words that we're going to use? So I'm going to use this. So I'm going to write down this first. For every 1, now what are the units of x? What are the units of x? Well, the unit of x are hours. For every 1 hour increase in what is x? X is hours studied. So every 1 hour increase in hours studied, or in hours studying. So every 1 hour increase in hours studying. So every time you increase the hours studying by 1, what happens? The percentage on the test, because that's what y is, the percentage on the test will, now is it increasing or decreasing? What do you guys think? Is it increasing or decreasing? If I spend more time, no, you don't have to draw the graph. If I spend more time studying, will my percentage increase or decrease? Increase, correct. Thank you very much, guys. It will increase. Will increase by the gradient and units. So what's the gradient? The gradient is 15 by 15%. Perfect. And that's our interpretation. Maybe it should be by gradient and units, not by So that's my bad there, but still, you get the, hopefully you get the idea. So, and we can maybe do another example as well, but I just wanted to, whoopsies, this phrase. For every 1 unit of X, what is X measured in? Increase in X, what is X? The Y, what is Y? Will increase or decrease by whatever gradient units. I have not, although I've used the term 15, I haven't said the gradient is 15. That will not work. That's why I've done it. Now, could you rearrange this and say the same phrase in a different way? Yes, you can. But what we're doing is we're giving meaning to the gradient. What does the gradient actually mean? The gradient means if you study for an hour, if you study for an hour, your percentage should go up by 15%. That's what the gradient means. If you had written that down, that would have been fine too. But I'm giving you guys this fill in the blank cookie cutter example so that you can use this. And this should work with majority of your majority of questions. So just keep that in mind. Now that's the gradient. We all know with an equation, there is always a gradient and a y-intercept. So what does the y-intercept mean when we talk about interpreting things? So let's grab a look at the y-intercept. The interpreting the y-intercept. This is giving meaning to the y-intercept. My cookie cutter phrase that I always suggest that people use is this one here. When X, now when we don't say X, we say X. We just say whatever it is. Whenever the X variable is 0, the Y is y-intercept units. So let's give an example. Let's look at this in an example. So every year, a person measures the height of a plant in meters since it was bought. The plant's height increases according to the regression equation y equals 0.4t plus 0.5. So we're going to attempt to turn this in, we're going to attempt to interpret this question. So let's figure this out. What I'm going to do is I'm just going to fix this a little bit. I'm going to give myself some room because what I've done is I've made this pretty big. I need to give myself some space down the bottom. Whoopsie, sorry guys. There. So before I start this one, because they haven't given me the X and the Y and what they mean, I'm just going to quickly do this. So X equals time, and it's measured in years. And in this case, Y equals height, and that's measured in meters. So when I redo this sentence, let's go. When X, now X in this case is time. When time is 0, now this is going to read a bit weird. When time is 0, the Y, the height is, now what's the y-intercept? Y-intercept is 0.5, is 0.5 meters. When time is 0, the height is 0.5 meters. Now, this is of course a classic one where those of you guys that have written, those of you guys that have any mastery of English can probably see that this can be rewritten when time is 0. So you might just want to say at the beginning or at the start, the height is 0.5 meters. The reason that I'm saying, okay, so then you might say, why don't we just start everything with at the start? Well, remember, not everything is going to be measured in time, units of time. Sometimes we may have units of length, in which case, if you write down at the start, that might not make sense. If you're measuring the length around certain vegetables or certain fruits, and using that to estimate the mass, you can't say at the start because that won't really make sense. So what I'm just trying to say is it makes sense here, but it won't always make sense. So when time is 0, that seems like a really weird way to say it, but still it does still work. So both of those answers in the bottom are correct. And again, what we're doing is we're giving meaning to it. What does it mean when t equals 0? What does that mean? So yeah, it means what the height was at the beginning. Some teachers will tell you guys, pardon me, some teachers will encourage you to manipulate that equation to make it make more sense, to say at the start. I'm just trying to give you guys something that will always work, and then you guys can base it off that. Now I'm going to change the slide in about 30 seconds to talk about the very last slide, which is not, I don't think has got any interpretation on it, but it's still worth talking about. Okay, so let's now talk about one last thing, which is we're going to finish up on this idea. Well, not quite finish up. We'll talk about a couple of other things. Sometimes it doesn't make sense. Just be aware that not all things make sense. So a person's height, a person's weight in kilograms can be predicted by their height in meters using the formula W equals 50H plus T, 10. So that means if you are, let's say 1 meter, if you're like 1 meter 80 tall, then you would say W equals 50 times 1.8 plus 10, which is going to be what, 90? Or 100 kilograms. That's sort of what this formula is suggesting, how you might use it. But you could also look at it at this. When the person, so let's just say you were trying to interpret the y-intercept, right? So if you try to interpret the y-intercept, this is when the person's height is 0, their weight is 10 kilograms. And then you might get to the point where you realize, wait, hold on a second, that doesn't make sense. How can someone with 0 height have weight? This gets to this point where you're like, wait a second, hold on. So that doesn't make sense. You're also saying that if you are 1 centimeter tall, then you will weigh about 10 kilos. It doesn't make sense. It's just it's not logical. This is again a problem with extrapolating. This equation might work really well for people between 1 meter and 2 meters, but it doesn't work for anyone smaller than 1 meter. So what you would say in this sense is you'd say the y-intercept cannot be interpreted. That is actually a valid answer here. Why is it a valid answer? Because it doesn't make logical sense. You will know when it doesn't make logical sense, because what you'll be doing is you'll be halfway through writing this sentence like this down, and you'll be like, wait, hold on. Does that make sense? You know, does it logically make sense to have, you know? Yeah. And so sometimes it doesn't make sense. It's very, and that's usually because of certain circumstances that happens. But yeah. Now, what we'll do is I think I will end this lesson on one more. I want to go back and I want to look at one more example, and then we'll finish up for today's lesson. Okay, which other slide? Someone just missed me saying, sorry, I didn't get enough time to copy down the other slide. That's okay. What do you mean? I haven't changed the slide, have I? Oh, whoopsies. Sorry, I didn't mean to go. Whoa, what am I doing? I didn't mean to go forwards. I apologize. Sorry about that, guys. I was trying to give you guys a chance to write this down. I didn't mean to go forward. Sorry. Carry on. Oh, if anyone asks, by the way, I'm too much of an old boomer to know what this means. I think it means some kind of astonishment about not understanding something. So yeah. Okay. Let's look at one last thing. Last thing I thought I would do is I was like, okay, I want to go through one more example with you guys. And I'm going to save this last thing until maybe next week, but I'll figure that out then. So what I wanted to do is I wanted to go back and maybe look at a equation. And I thought the one that I thought about doing was I thought I would look at this equation, this thing here. So we're going to go back to this slide here. So what I wanted to look at is I wanted to look at this equation here. And I thought, let's see if we can interpret this. So if I wanted to interpret it, I would start, let's start with interpreting the gradient. So for every, you don't have to copy this down, ladies and gents. I just thought I would show you another example. For every one now, what is the units of, in this case, unit of x? Well, we're talking about atomic mass number. For every one atomic mass number, for every one atomic mass number increase in x, which is atomic mass number, okay, what's the next bit? The y, what's y? Y is melting point, okay. The melting point will, okay, it's a negative. So this time we're going to say, if it's a negative, we're going to say decrease, will decrease by, okay, by what? By oh, the gradient and units. So by, what's the gradient? By 52. And the units are, well, it's melting points, it's probably degrees. For every one atomic mass number increase in atomic mass number, the melting point will decrease by 52 degrees. Nice, excellent. And then someone might say, oh, sir, why don't you do the y-intercept? Well, let's see how we will do the y-intercept. What we would do with the to do the y-intercept, we need to say this. When x is 0, so we would write down when the atomic mass number is 0. Okay, when the atomic mass number is 0, the y is y-intercept units. The melting point is 2,805 y-intercept units, 2,805 degrees. Now, for anyone that's doing chemistry, you should be like, wait a second, that doesn't make sense. I'm hoping if some of you chemistry students are looking and thinking, wait a second, you can't have an atomic mass of 0. That doesn't make sense. In fact, this whole sentence at the top doesn't make sense. What atom has an atomic mass of 0? That would be no protons. How can you melt something that has no protons? So in fact, you would not write that. You would say the y-intercept cannot be interpreted. But if you are not a chemistry person, if you're like this, if you are a sciencey person, if you're a cute little like legal studies person, you're looking at this and you're like, what? Then don't stress. Like you can just write the top one down, that's fine. But when it does, this is an example of a time when the y-intercept wouldn't make sense. So therefore, it's just sort of a point to be like, hey, cool. Yeah, it doesn't always make sense. For example, in this question here, where we've got a filling the petrol tank up, this sort of does make sense because it sort of says when the y-intercept is 0, this is the car is not moved. So when the distance traveled is 0, the amount of petrol in the tank is 40 liters or whatever it is. That's how you would interpret that one there. So that in this one here, it does make sense. And you could interpret the gradient and you could interpret the y-intercept for this question here. So that leaves us with you guys working on the last one here. After 7F, 7G we've already covered. You would be looking at, because that's the line of regression. I don't think it's 7I. Is it 7I? Is there one where we have to interpret things? Where is the interpretations? Are they in 7F? I swear you guys had to 7H. So I was right. So it's 7H. So 7H, you've got, like, for example, here we've got the equation. It says, for this, we write down the value of the intercept, interpret the intercept, write down the value of the gradient, interpret the gradient. and so on and so forth. So there are about four questions with regards to 7H. And then that's pretty much all that we need to do.